Let's look at some additional examples of how to use the noble gas orbital notation or electron configuration. The orbital gas or noble gas configurations, these are a shorthand way to do the above processes. So for this example, I'm going to go ahead and use oxygen. As you guys recall, oxygen is my favorite element, so I want to go ahead and use that example. So if I am looking at my periodic table, oxygen is here, which in this region is our p orbital. So when I did the other examples, we were using elements that were down here in D, but we can also use the noble gas configuration for elements that are in S or in P. So again, this example, I'm going to use oxygen. So just like before, the first step that we need to do, so step 1 is locate the noble gas before the element. So in this case, if I go backwards and I'm looking for a noble gas that has a number that is less than the number on this element. So since this is 8, I cannot use 10 because that is a higher number. So I have to go to helium. So I'm going to put helium in brackets. The next step, once I'm at helium, I need to go down from number 2 to number 3. Notice that this, if I count these as energy level 1, 2, 3, 4, 5, 6, and 7. So this lithium is in the second energy level. So I'm going to put 2 for the energy level. And these elements are in our s orbital. So I'm going to put 2s. Our s's, since there's only 2 elements and each element has an electron, in the s orbital we only have 1 suborbital. So I'm going to draw a line for the suborbital. Then I'm going to place my electrons. So I need an electron for lithium and an electron for beryllium. So I'm going to have 1 up arrow and then 1 down arrow. After I've left beryllium, which is number 4, I'll move over here to where I have boron, which is number 5. In the P's, we start with 2, 3, 4, 5, 6, and 7. So in this case, we are now in the second energy level, and this orbital location is P. There are 6 elements across, so that means that I have 3 suborbitals. So 1, 2, and 3. Now I'm going to count my way across to oxygen. So I have 1, 2, 3, 4. So that means that I need to have 4 electrons. So I'm going to have 1, 2, 3 by following Hund's rule, single before double, and Pauli's exclusion principle of the electrons have the same spin when occupying different suborbitals. I then need 1 more electron, so I'm going to put it back into the first one, and because of Pauli's exclusion principle, it needs to have a downward spin. So you can use full arrows or half arrows to represent as long as you have 1 arrow for each electron and the electrons have different spins when they occupy the same. So that was my step number 2, is count forward from the noble gas. And I'm going to say step 3 is add the energy levels the suborbitals and the electrons. So this is all for orbital notation for the noble gas, aka shorthand, the shorthand version. So now that we've tried one that is in the p orbital, let's go ahead and try one that's a little further down that is in the s orbital so we can get another example. So for this one, I'm going to go further down in the periodic table. This time I'm going to use strontium. So my example is number 38 SR. So if this was longhand, I would need to have one electron or arrow for each one. So since I'm using strontium and we're going to go ahead and use the noble gas configuration, if we look at 38, we need a number that is less than 38 that is in the final column of our periodic table. In this case, number 38, the number that comes before it, is going to be number 36, which this element, the noble gas, is krypton. So we'll start with our Kr. That is our step number 1. Next, we need to count forward. So from krypton, we are going to go to number 37, which is rubidium. This is in the 5th energy level, so I'm going to write a 5. And these are all in the s orbital, so I'm going to put an S. And all s's have one suborbital. I'm going to need 2 electrons, and that means this is going to be filled up completely. Now, if I want to go back through and I want to look at the noble gas electron configuration. So remember, with this, we remove the arrows and place the number of arrows as superscripts. So if I go back and I look at oxygen, if I look back at my original example for oxygen, this is my example for oxygen right here. I'm still going to put my noble gas in brackets. Now, instead of the arrows, I'm going to make superscripts. So I'm still going to put my energy level of 2, my orbital of s, but now I'm going to put 2 as my superscript to represent the number of electrons. I then have 2 as the energy level, p as the orbital, and I have 5 arrows, so I'm going to have 5 electrons. So that is what I'm going to place here. If I look at strontium, again, I'm going to take my symbol krypton, and then we're just going to write what follows, which is 5s, and then remove the electrons as arrows and put it as a superscript, which in this case would be 2. So let's do one more example using an element in the D block, and we're going to do it for both of these types. So for this example, I'm going to go ahead and I want to use NB, which is number 41. So again, I'm going to look for the noble gas that comes before NB. So since this is 41, I have a choice of 38 or 54. I'm going to use 38 because that number is less than 41. This noble gas then is krypton. From krypton, I'm going to come down and I'm going to look at number 37, which is rubidium. And I am in the energy level number 5. This region here is the S, and I'm going to have one suborbital, and I'm going to go all the way through. So I'm going to have 2 electrons here. Next, I'm moving into the D block. Now, D block always is 1 energy level lower than the S block. So this is 3, 4, 5, and 6. So I'm moving now into the 4th energy level. This region is the P orbital, and since there are 10 elements across, I need to divide that number by 2 to find out the number of suborbitals. So my number of suborbitals are 5. So we are going to draw all 5 suborbitals even if we do not fill them. We need to show that they are empty or blank. So I'm going to count across how many elements I have. 1, 2, 3. So I need 3 arrows. Following Hund's rule, I need to go single before double, and following Pauli's exclusion principle, they all need to point in the same direction. So even though these 2 suborbitals have no electrons in there, we are still going to show that they are empty. Now, if I want to convert this into the Noble Gas Electron Configuration, I will just take that information and remove the electrons. So we have 5s2 and 4p. Sorry, this was not p, this is d. My correction. 4d, because this is in the center, the d block, not the p block. And then I only need to count the number of arrows and put that superscript here. So I'm going to rewrite this so it's easier to read. That is krypton 5s2 4d3. All right, let's look at one more example of using Noble Gas Configuration on the element americum, which is element 95. This element is right down here in our F block. So again, what we're going to want to do is we're looking for a noble gas that is the closest to 95 without going over. In this case, this element will be radon. From radon, we're going to count down to 87. This is in the 7th energy level, and it's in the s orbital, and we have 1 suborbital, and we have 2 electrons that can fit here. So we're going to go up and down. Radon is 88, and if we look at where we're trying to go to 95, so we need to go down to 89. All right, so we're down at 89, which this area down here is our F block. F block will always start 2 numbers, energy levels lower than S. So this here will be 6, and this will be 5. So from francium, we go through our S7, and now we go down to 5, and this area here is our F block. So we're going to have F. If we look at how many elements we have on this row, we have a total of 14. When we divide 14 by the number of 2 electrons per suborbital, that means that we are going to have 7 suborbitals. 1, 2, 3, 4, 5, 6, and 7. And our element here is 95. So we're going to literally count across 1, 2, 3, 4, 5, 6, 7. So following our Hund's rule, 1 electron per suborbital, and we have 7 suborbitals, so each one of these suborbitals will only have 1 electron. If I want to do the electron configuration for this, I just remove those electrons that are arrows and make them subscripts. So I have 7s2 and 5f7. All right, now you guys should be able to try doing some more practice. So let's have you guys try that and go back into Canvas for the